Welcome back to Notes for Engineers. I'm Alistair Cook, and today I have the pleasure of being in Boston at the head offices of Infinio. Infinio has been a great friend to me personally and to the vBrownBag podcast, and so it's a great pleasure to be here with the people in person. And I'm joined by Scott Davis, who is the Chief Technical Officer here. Welcome, Scott.
Great, Alistair. Great to talk to you again. It's been a while, a whole few weeks.
A few weeks. It's been an awesome couple of weeks for me being back over here and seeing so many people again.
Mm-hmm. So I'm glad to talk to you today. What would you like to talk about?
We're going to start off with the foundations of what it is that Infinio does, and then head on into some of the more advanced things that you may not have realized that Infinio does, and drill into some of them.
Sure, great. So Infinio is a solution that improves performance in virtual infrastructure. Should be widely known, virtualization, virtual data centers, software-defined data centers can cause issues with traditional storage array designs. There are a variety of solutions that can address these kind of limitations, but many of them involve ripping and replacing your existing storage and replacing them with different styles of array, whether those are executing across the server in what's now called hyper-converged infrastructure, or traditional new arrays, either hybrid or all-flash arrays. Infinio makes use of memory spread out across a collection of systems in your vSphere infrastructure in order to dynamically cache the workloads, thereby improving the storage performance of your existing arrays without this level of disruption.
So, and I particularly like with the Infinio solution that there's a really low barrier to entry, that you can get started with a trial. You can get this into play and see the effects of the performance improvements with very little change in your environment, and then scale it up and scale it out across your environment as you need.
Yes, that's a great point, Alistair. In any of these solutions that are disruptive, it's not just that you're replacing your storage, then you then have to migrate your data into this new type of data store, new device. And moving back and forth it's operationally intensive. With Infinio, we talk about our solution as downloadable storage performance, meaning it's all software, and it inserts itself in front of your existing storage infrastructure seamlessly and transparently. There's no migration of data in. There's no migration of data out. You can download and try the solution, and you can just as easily disable it without any migration of data whatsoever, which makes it very easy to try and see the benefit that it'll deliver in your infrastructure.
So we're going to drill into something a little more advanced in the solution. So I think we'll come back and do another video where we look at the foundations of it and how easy it is to deploy on those things. But we wanted today to look in and think about how your solution is architected to make the best use of one of the most expensive resources you have in your vSphere environment, which is the RAM and your ESX servers. Mm-hmm. And particularly we're going to look at how your caching works.
Great, great. So caching is a well-known technique in computer science in order to improve performance. Traditionally, though, memory caches for I/O, which all the major operating systems, guest operating systems, have built into them in a fashion, okay, is location-based. Location-based means that in a diagram here, virtual infrastructure caching can be very effective if done in the right way, because there's a lot of common content across all the VMs. When you cache in an individual VM instance or an individual physical system, it's typically using location-based caching. So my VMDK here, I have a block in this particular image, and as you see across the infrastructure here, we have lots of common content across it, illustrated by the block A in different locations in these VMDKs having the same content. Now, in a traditional location-based cache, when I go to fetch this content, I would load it from here, and I would load this content into memory. And if I cache it, it will be in a memory cache in this image. And that location in memory would only be re-referenced if the exact same image went to reference that content again. If I go to reference A over here, that would be read in from a different location on disk, stored in a different memory location here. Okay, so these caches would be independent. And of course, if you have a lot of the same content across these VMDKs, that's going to eat up a lot of memory in aggregate across all the caches.
You'd see that commonality in a lot of vSphere environments where you're deploying VMs from the same template, or you're using something like link clone functionality with vSphere or with Vue, where it's exactly the same content across lots of VMs.
Yeah.
But in this caching architecture that we've drawn so far, every single instance of that same data is occupying cache, and so we can't hold as much unique data in the cache that way.
Exactly. So this is how a traditional cache might operate. And of course, you could do things like you could turn this into a distributed cache, but that doesn't give all that much benefit in
So we're
where you're
going to
doing.
mirror these multiple copies that we've got of block A. We're now not only going to store multiple copies, but we're going to store each of them twice.
Well, yeah, yes, good point. If you want to do something like Redback or something, but but the point is, when you're location based, you really can't identify this commonality. Infinia works very differently from this. Okay, we get away from this altogether, which is that we're a content-based cache instead of location-based cache. Okay, our mechanisms internally are identifying the content and locating it within the cache by hash signatures that reflect the common content. So when we go to cache something, we go to reference block A, we're going to not generate a cache entry based on its offset and location within its VMDK. We're going to cache it in a distributed memory cache. We're going to cache it once and only once, but we're going to cache it based on a hash signature that reflects that content. So now, when we go to reference read that exact same content from another VMDK, we're going to discover and identify that when we go to read this in from the VMDK, we're going to identify and discover that this has the same content. So it's actually going to point at this cached copy. Okay.
So this is essentially deduplication, and this is how all deduplication works. It's an algorithm, essentially a piece of math on the content of this block of data, so that we get a number, a single number out of it, usually a 160-bit number, so that every grain of sand in the entire world could have its own 160-bit number. We would have no collisions on them. Mm-hmm. That lets us know for sure that this block, when we see it over here and we get the number through the algorithm, it's exactly the same data as if we run this block of data through the algorithm. And so we know we're storing just one copy of that across the whole thing. It's essentially dedupe for this cache.
That's correct. So it's deduping the memory. And it's also content addressable. And those are actually two related but different attributes. The content addressability lets us identify that across your virtual infrastructure, across your software-defined data center, there's lots of copies of the same data. And we can identify that and store it once. Secondly, it also uses much less memory. So you can have a far smaller cache and have it be as effective as a much larger cache would be.
Yeah. And this distributed global cache across the host also means that a single virtual machine with a very large working set, we can have that cached across multiple of our hosts. If there aren't too many other things with a large working set, we can deal with a larger working set across a single VM. And that's, if you follow what I was doing with the vBrown bag with Irfan from Cloud Physics, he was talking about working set sizes and identifying how much cache you need. This lets us work with a much larger working set really effectively.
Yes, that's absolutely correct. And one of the other attributes of this design is it's a completely evenly distributed scale-out architecture, which means that the load is balanced evenly across all the nodes across the cluster. Okay, and it also means that you can it's transparent to operations such as vMotion, that as the workload moves around the cache maintains its effectiveness.
There's no warming up as it moves from one host to another.
Exactly.
And warming up sounds like a good thing, but it's a performance penalty immediately after that move. So cache warming is something you want to have either not have to happen or to happen extremely fast.
Correct, Alistair.
Great. So this is fundamentally letting us use a relatively small amount of RAM to cache a large amount of hot data across our environments. It's going to be really effective where the VMs have the same content in them, which I guess is VDI is the poster child for that, and where we see the projects going so far off the rails because the storage performance is wrong. And Scott knows about this from his time at VMware as the CTO for end-user compute there as well. And my experience has certainly been that storage going off the rails was what killed VDI projects effectively. Yeah. I guess that was one of the things that attracted you to coming here a while ago. Definitely.
This is actually a general purpose solution, but it does have a lot of benefit for VDI. VDI was unique amongst virtual workloads for two reasons. One of them is that you want virtual desktops to cost less than physical desktops, and in order to do that, you wind up with much higher numbers of VMs on the same number of servers. So it's higher density, but virtual desktops have a unique attribute that I/O performance is not gauged by throughput or throughput of background activities. It's satisfaction with virtual desktops is driven by user experience, which very much reflects latency. Okay, low latency on operations geared to the windows that have focus. Okay, so latency of your storage infrastructure and higher densities are key to a successful VDI deployment. And this non-intrusive mechanism of being able to deliver fast latency by delivering content out of memory for common content across the VDI images is a sweet spot for Infinio. But there are a lot of other sweet spots as well. In fact, some of them include DevOps, general purpose workloads. One of the other things with VDI is a lot of times customers would like to be able to mix their storage infrastructure, use the same storage infrastructure for VDI and server workloads. And Infinio makes that a real possibility as well.
Yeah. Well, I blindsided you with the VDI one, but I knew you'd be able to cope with us. We should bring this one to a close. We'll do some more videos talking about the Infinio solutions. And so thank you very much, Scott, for joining me.
Thanks, Alistair.